Hi everyone, my name is Michael Alderman. I'm a landscape designer at Timmins Group here in Raleigh, North Carolina. And today I'm going to go through today's site civil lesson. I am a site designer at Timmins Group and I work with civil engineers a lot. So hopefully I can give a background on civil engineering for you. So let's dive in. So let's go over today's presentation agenda. What is civil engineering? That's what we're going to cover. We're going to talk about a typical project that I've worked on here at Timmins and Raleigh. And then we're going to focus on your project. And how we do that is through understanding site analysis. We're going to get into what contours are and how to site a building. So what is civil engineering? Civil engineers are really just designing infrastructure projects in the public and private sector. So that's all your buildings and roads and how those connect in the real world. So think about your typical day, you're going to school, all the roads, all the lighting, the way the school is located and how it's all put together is all kind of conceived by civil engineers and sometimes with the help of landscape architects. So what's my typical day at work? We work in a large office. There's over 100 people here at Raleigh, and there's civil engineers, landscape architects, there's stormwater engineers, and this is pre-pandemic when we're in a shared big open space. We're able to ask each other questions and collaborate with our other consultants. So where do we fit in the big picture? In a typical project, the owner might employ the architect, who then he has his own consultants. That's a constructional consultant, MEP consultants, and anyone else. And then the owner might engage a landscape architect, a civil consultant, or a geotech separately. Sometimes we work directly for the architect. So just depending on the project, whether it's a big building project, we might work with the architect. If it's more landscape architecture or civil heavy, they might lead the project. But those kind of dash lines there show that, we're constantly talking with the architect in order to, fulfill what the owner needs from us in the project. So what software do we use? We're always in AutoCAD Civil 3D. Civil 3D is really split up into two spaces. There's the model space where you do all your drawing, all your line work, your details. And then in a layout space, that's where, all that drawing comes forward. And that's, where we're printing. When we're drawing, all those lines and points can be placed on different layers, and we can give those different settings, and that'll, be how it's printed. We've got the toolbar up top, that's all the different kind of lines and annotations and setting up the drawing. And then the command line down the bottom is kind of your shortcuts to really draft quickly. So what are the kind of typical projects a civil engineer works in? Here at Timmins, we've got residential land development, we've got commercial projects, so think of gas stations or retail, public projects like schools and urban spaces, and then stormwater projects like greenway crossings and anything to do with creeks or rivers. So this one we're going to go through today is the Johnson Community College engineering building. We have just finished design. It's about to go under construction. We're really excited about this project. So kind of going to go through, how we went through the process of siting that building and coming up with a construction document package. So the first thing we want to do is site a building, but we want to know what our considerations are. So we know that the size of the building is based on the amount of class space that they wanted for this engineering building. They had different classes with different needs, and they also had an auditorium. So pretty early on, we knew how big that building needed to be. We also knew we wanted to retain some of those existing trees. The pine trees really set a kind of aesthetic for the campus as this campus in the woods. And then they also wanted to improve their driveway access. So Right now, when school gets out, there's only one driveway to leave that big parking lot. So one thing that we were looking at is connecting that driveway to that secondary road on the right side. And then also allow for future campus expansion. So right now they have kind of a growing campus. They've got one new building that they're planning on, their engineering building, but later down the road, they might want to add another building or add more parking. So giving them that flexibility, we want to keep that in mind when we're placing our building. So the first thing we want to look at is boundary setbacks. So a setback is just the offset from the road that we can't build in. Luckily for us, it doesn't go too far into the site, so we've got a lot of flexibility in where we can place our building. Those two green and blue lines, that's the sanitary sewer and existing water lines. So we'll come back to that later. So access, so I talked about how they wanted to connect that driveway through, and that really kind of sets the space up, and we know our boundary of where we want to place this building. So even though, you know, the building is only about half the size of that space, it takes a lot to place a building. And you can see that, you know, the impact to the existing site is, we know that there needs space for a plaza. We need service areas for trucks to take rubbish away and access utilities. So really, the best place to keep those existing trees was at the entrance. We still get that initial aesthetic when we drive through that road, and it also kind of frames the building. Luckily for us, the flat area, this whole site was pretty flat. We actually had to try and lift this building up to make sure that the stormwater was draining away from the building. You don't want you know, the rain coming down and sloping towards the doors and the building foundations, because that'll give you plenty of problems down the road. And then what's the relationship to context? So you can see that building down the bottom left corner, we left that area next to it as future expansion potential, whether they want to expand that building or build a new building. And then above that, you know, there's room for parking and connecting to that new access drive. And finally, what is our proximity to utilities? So you can see the blue line is connecting along the road, that's the water line. And then the sanitary sewer is crossing the street. And so the civil engineer is gonna figure out all those calculations in order to make sure that the water is gonna move down the pipe system. It's gonna have the right pressure, and the pipes are large enough to carry all that water. So we're in the next phase of the design. We've done our site analysis. We know where the trees were, we knew where the flat areas were, and we knew the size of the building. We kind of came up with that development diagram, and now this is kind of that conceptual site plan that we can move forward. And once the owner has approved this, we can move into construction documents. So typically we'll have a demolition plan where we'll show all those trees that are removed, any existing utilities. We'll have a layout plan, which shows all the built elements, a grading and drainage plan, a utility plan, and a planting plan. Once we have all those documents ready, we'll be able to bid the project to a contractor, and they'll be able to hopefully construct it based on those drawings. So let's go into a little bit more depth on what construction documents are. So even though we're moving into that kind of 2D space where we're drawing, making construction documents, we're going to continually look at the design of the building and the pathways around it. Here on the left, you can see there's 3 points of access, whereas on the right, we have kind of only 2, but one of them is a lot larger, trying to gather all those pedestrians for the large parking lot adjacent. Whereas on the left, we were trying to create a shortcut for people that might be walking from different parts of the campus. So you can see in our layout plan, we went for that shortcut. We have that flexibility with the 3 different entryways. So a layout plan is all those built elements, where the building is located, the sidewalks, the driveways, and the plaza. We've also got that service area, the trash cans out the back, and all the signage that's goes along with that. So what does a grading plan look like? We can get into what contours are later, but here we have the building located, and we have a lot of what we had in the layout plan, but now we're showing where we're changing the contours, where we're lifting the ground up or pushing it down. That's all about accessibility. How does someone get from their car to the building entrance in a safe and easy way? And also it's about stormwater drainage. We can't have the water draining back into the building. And here we're showing how stormwater was being collected off the roof, transitioned into the pipes and into a pond, and then back into pipes. And I'm going to go through that process a little bit more in depth. So here you can see we flipped the view. That building roof is sheeting water into outlet drains, and they're going into a pipe. That pipe's feeding into an outlet structure that feeds the water into a dry detention basin. So the main idea here is to slow the water down in large rain events. So the civil engineer is going to calculate how much water is going to be collected in that 1 in 100 year flood event. A lot of rain is coming through. We want to slow that down so it doesn't take all those nutrients off the road and things like that. And then, put that straight into our water system. We want to slow the water down, let it infiltrate slowly, and then send it back into the system. And so what does that look like in real life? So you can see a lot of the stormwater plantings of the grasses and kind of shrubby trees, as well as the rock channel. So we will go through our construction documents and come up with construction details where we're showing utilities, we're showing the ground plane in section. And this is really what the contractor is going to use to help them build what you see in those pictures. Eventually, we'll have a final construction package, and we'll be able to start building. So the first thing we're going to do is go through demolition. We're going to clear the area and set a flat pad for our building. Once that's set and we're out there every couple of weeks making sure we're answering contractor questions, just making the process really smooth and easy, and guiding the contractor as they build. And hopefully it looks something like the 3D rendering we came up with kind of at the start of this process. So let's talk about the site activity at Dorothea Dix Park. The first thing we're going to want to do is understand the site through site analysis. We're going to do that through mapping. We're going to look at photos and in-person site visits. So we do this often. A lot of times at the start of the project, we'll spend time out there and just kind of understanding the site. So you can see we've got existing trees along the boundary. There's 2 historic houses being renovated. And so we're going to want to think about these things and the relationship to the driver and the rest of campus when we're designing our buildings. So let's zoom out, and we're allowed to use a system called iMaps. We kind of can take in a whole context and what's already out there. You can see the kind of larger driveways that frame this space, as well as the existing utilities. And all those things we talked about earlier, like setbacks, access points, what that footprint is, that's going to be our site analysis that helps us really understand why we're making decisions when we're placing the building or placing the driveway on site. As well as, when we look at the big picture, we can start testing our ideas. Where does that sanitary sewer connect into? We've got 2 options available to us. One is on the left side and one is on the right side. And we can use those existing contours to understand, how that site is sloping down the hill. And we know that the sanitary sewer needs to flow with gravity. And we want to connect to that downhill potentially. On the left side, we know there's some historic buildings that we want to avoid. And, but maybe that means we have to lose a couple trees at the bottom of the site in order to connect our utilities. So let's understand what contour elevations are first before we get too far into this. The best way to do that is just by looking at the information that's provided. So we can use the numbers to help us understand the direction of the slope. So it goes from 10 to 20, and then there's a gap, and it goes 40 to 50. So I think we know it's going uphill in increments of 10 feet. And so my guess is that it's a 30. Yep. See, that was pretty easy. But there's plenty of ways that we can read maps. And you can do that on the top view or the side view. And the more information we have, the easier it is to kind of understand those 2D lines. So how do we know what the slope is? The closer together the lines are, the steeper the slope is a good rule. You can see the red arrow crosses 2 lines or 3 lines, but it goes up 2 contours. And we know those are 10 feet each. So we know that's going up 20 feet in height. Whereas on the right, we have the same arrow in blue, and it only goes up 1 contour. So it's only going up 10 feet in the same amount of distance. So we calculate that by using the formula gradient equals rise over run. So gradient is the slope, rise is the height that you're going up, and run is the distance that it takes to go across that slope. So if you look at the blue arrow, the gradient is, we'll sub in the rise, which is 10 feet. We know it goes up 1 contour, and the run is 40 feet because we know that the arrow is 40 feet in length. So the gradient is 1 over 4, which is 25%. It means we're going up 1 contour, 1 foot every 40 feet. Same thing with the red arrow. The gradient equals a rise in 20 feet over a run of 40 feet. So that's a 50% slope. So you can see that's going up twice as much. And so the best way to understand contours and flat maps is practice visualizing them in 3D. We can use our imagination and look at the plans and see, okay, 40 is the highest point on there, so that must be the highest slope and hill. And then we can, trace those contours and figure out that, okay, the other hill is only going up to 30 feet. So we're going to test our cutout engineering scales, or if you print this at home and you have a scale, you can follow along with me. So we're going to line up our scale. Yep, it looks like 0 equals 40 feet. So that 1 inch line is equal to 40 feet. We're going to figure out what a setback is first. So what is a setback? A setback is the minimum distance which a building or other structure must be set back from the road. So you can see there, the street right-of-way is also just an invisible line that just shows the property that road is owned by the city or the state. And then the setback is obviously an offset from that. So we're going to line up our ruler using our 40-foot scale, and we're going to measure 20 feet, and we're going to do that on both sides of the driveway off the edge of Umstead Drive, and we're going to line up that line. So you can see that's a 20-foot setback off Umstead Drive. Next thing we're going to do is place our 28 by 8 trailer. We know that there is kind of some steeper areas and a gentler slope by how close together those contours are. So it looks like there's kind of a flatter area on the left side. That's where I'm going to place my building. And I'm going to place it with the contours so we have a less distance across in order to make that flat area. And then, what is a curb cut? So it's just, a curb cut is a dip in a sidewalk and a curb that enables a vehicle to drive to a driveway. So you can see the existing road match up to the driveway, and there's typically a 6-inch curb that crosses the property. And so we're just going to take out that section of the curb, and then we're going to either use like a 10-foot radius to pull that curb into the driveway to make a nice gentle slope, or we can gradually pull down that 6-inch curb parallel with the road, as you can see in that third example, and create that level pad so we can easily get from the road to the driveway. So I'm going to let you play with that. You can line up your ruler and figure out what 50 feet is from that center of the intersection. But don't be afraid to test your ideas. There's a lot of different ways you can do this. Here I've got an example where I'm showing 2 parking spaces that are offset from the road, and also a driveway that lets you, pick up the trailer and drive away. But we're kind of close to those trees, so maybe we want to pull it back and have those parking spaces, further up the road, which leaves us plenty of room for expansion, potentially a driveway and another trailer, or just a kind of larger garden area. Or maybe we want to go deeper into the site and, connect with a sidewalk that does something a little different to the other sidewalks on the site. Don't be afraid to place some trees down and kind of create a space and shield that view. So with that, I'm gonna jump back on. We're gonna answer any questions. Hope that helped you understand a little bit more about civil engineering and site design from the perspective of a landscape architect. So looking forward to answering any of your questions. Thanks, bye.